Welcome to Section 4, Applications in Natural Language Processing. In this section, we're going to take a look at bag of words features as well as n-gram features, and we're going to use these features to do tweet classification. Furthermore, we're going to build a tweet bot that generates tweets using concepts from language modeling. And we're going to wrap up with latent Dirichlet allocation, LDA. We're going to learn about the fundamentals, and we're going to use LDA to do natural language topic discovery within news articles. Essential feature extraction, bag of words, and n-grams. In this video, we're going to take a look at bag of words text representation. We're going to do a deep dive and talk about some of the issues with simple bag of words and how to correct for these using things like n-grams. We're going to talk a bit about language modeling as well as cover full n-gram bag of words representations. So to give you a sense of what bag of words representation looks like, we're going to take a sample sentence. I went to France and ate some pastries. For this sentence and for all of our sentences, we can create a vocab. And this is just every word that appears in any sentence that is in our data set. And we associate a number or an index with each of the words in the vocab. So to create a bag of words representation, we go through each word in the vocab and we check, does it exist in the sentence? So here, Italy. Italy does not appear in the sentence, so we mark it as a 0 in our feature vector, and the 0 is in bold. And we move along to France. France is in our sentence, so we mark that with a 1. It's there. Then we check for pizza, not there. We check for pasta. We check for pastries, and there's a hit. Pastries is in our sentence. And we can go through each of the words in our vocab in the same fashion to create a feature vector of what words appear in this sentence. So here's the feature vector for this sentence. And each of the indices here represent if the word appears in the sentence or not. So you may have some concerns with bag of words, and there are some issues with bag of words. The primary issue is that there's no modeling of word order. We're just saying if a word appears or not in a sentence. And that is problematic because the ordering of words matters a lot in language. Secondly, there's no modeling of word frequency or even relative word frequency. We're just marking if it appears or not. So to cover some of these issues, we're going to talk a bit about language modeling. So imagine I give you the sentence, I went to France and ate some question mark. You might be able to complete this sentence using some of your knowledge about language. And you might complete it by saying pastries, or you might say pastry, or you might say pizza, that's still valid, or pencil, that's not quite right, or running, which is completely wrong, or some made-up word. So each of these are valid or invalid completions to the sentence, and some are better than others. We can model this as a probability distribution. What is the probability of the next word given the prior words? And we might see that pastries has a high probability than some made-up word like Wazelby. So within language modeling, we're talking about the probability of the next word. So this is called a unigram. And this is just the probability of a word appearing. So the probability of pastries is the count of the number of times pastries appears divided by the total size of the vocabulary. We can move on to bigrams. And what bigrams is, it talks about two words. What is the probability of the next word given the previous word? What is the probability of pastries given some? And we can calculate this by calculating the count of some pastries, the number of times that occurs, divided by the count of just the word some, the unigram. And we can extend this concept to trigrams and furthermore quadgrams and 5grams and so on and so forth. And it's the same idea where we take the count of the gram divided by the count of the gram that is lesser than. So to go about and create n-grams that covers unigrams, bigrams, trigrams, and so on, we take our text corpus and we can extract each of these. So now that we have our n-grams, we can treat this as our new bag of words. So instead, our previous bag of words just had one word represent each index. Our new bag of words using n-grams has our n-grams represent each of our indices. So as you can see, Italy is still there, that is a unigram, but we have a trigram right below it, came from France, and we have a bigram below it to France with the index 2, and we see in the feature vector it's marked as a 1 because it is in the sentence. So we can take the same concept as our bag of words and extend it using n-grams to get a fuller, more rich feature representation.